So let's talk about databases. Okay, just getting into queries. So let's talk about select queries. And so our goal so far, we've talked about how to diagram our databases. We've talked about how to start creating the schemas that restrict the data that's there and define the data that we're storing. We need to talk about how we query the database. Okay? And so what I want to talk about is the syntax that MySQL uses. Okay? So let's start with the full thing. Okay? Here's all of the clauses you need to know about in terms of why I create with MySQL. Okay? There is a select clause. There's a from. You're going to then have joins. There's a where. There's a group by. There's a having. There's an order by, and there's a limit. Okay? And we're going to talk about each of these clauses in turn. But if you're going to write a query, they do have to be in this order. You can't actually change the order that they're in. They always have to be in that order. SQL syntax says that. Okay? So I can't put the limit anywhere except at the end. Order by has to be basically here, having, group by, where, etc. Now, you'll notice the ones, there's several of these that are in square brackets. What I'm saying by that is those are optional. Everything in square brackets is optional. Anything not in square brackets is basically required. Okay? So we talk about what's the minimum that you have to make a query. To write a select query, what is the simplest version of a query that you can write?
Select column.
Select columns, like that part has to be there. Okay, so here's the simplest query in SQL. Select one. That's the simplest SQL query that you can write. Always returns one. Always returns one row, one column. That one cell, that one field has the value 1. That's it. This may seem weird. Okay? Why would I even want a query that simple?
Does the result contain the number 1, or is it one cell from any place at the start?
So the result set is, anytime I run a select query, by the way, it produces a table. Basically, it produces a virtual table. Sometimes we call that, I think the first reading that we did kind of called it a view. Brandon, you had a hand?
I was just going to say, like, maybe like something simple like that would just let you know that you're connected to the database and that it's working properly.
It can do that. Yes, it can. That can be helpful for that. I don't generally use it for that, but you could. So the result set, the table that it returns looks like that. Select 1 is the name of the column, and 1 is the value. At least depending on the database. Sometimes this might be just none. It might show you as the name of the column. Okay? Oftentimes, actually, I use it for things like, do I want to know if a row exists in context of that? Oftentimes, I'm using it to know if something exists or not. Okay? That's worth noting that you can do that.
How does that prove anything exists?
Because it usually has a little bit more to it. Like I might have a from and a where clause.
Oh.
But that's a valid, it's worth noting that that is a valid query. Select 1 is a valid query. Okay? And that's the simplest version of a SQL query that you can write. Okay. So let's talk about what more complex queries look like, more real world. So I might say select columns. Okay. It might look something like this. Let's say select star from products. Okay, so select star from products says I want to get all of the products as a result set. I want to get star says I want to get all the columns from that. So if I were to run this in Workbench, I think I have, let me pull Workbench up. So you can kind of see how this works. And I'm going to do this against the Sequila database. So new script, use Sequila. Okay. And if I'm looking at this database, I can see that it's got some tables, kind of expand that out. All right, and so we've got a film table. So if I do select star from film, can run that, and it will give me back all of the records. So that's an easy place to start. Okay, so if I look at all the records it's returning, looks like there are 1,000 records in that table, right? And there's an awful lot of columns in there too, right? So oftentimes we find, well, okay, I've got this really big table. Maybe I don't need all of the data in that table, right? So let's just pick off some of the columns, right? So if I'm saying I want to look at these films, maybe let's start by just picking off the title and the release year. So I can name those two. Oop. And there we go. So if you put between the select and the from, you can say which columns do you actually want, right? So that's kind of the addition there. Say, what columns do I want to add to the results? If you say star, it's everything, or you can specifically say I only want this and that. Cool. So you can use that select clause to limit what columns you get. Okay. Other things I can do in here. I can also add additional columns to the select if I want to. Let me go back to the star real quick, and let's see what else was there. So I have a rental rate and a rental duration. Okay, so maybe I'll use that. So other things I can do is I could say, let's take the rental rate and multiply that by the rental duration, because those are both numbers. And so I could run that. And then it'll give me this nice product column in here as a third column. So I can kind of make up columns any time I'm doing this query. I can ask for a column particular, or I can say, let's do some calculations with those columns. Now, you'll notice that the name of the result here, it says rental rate times rental duration. I generally don't want that. Okay? So I generally want to give those a name, right? Or we would say an alias. So oftentimes when you're doing these calculations, you may want to alias the resulting columns. So I might say this is the rental cost. And so I use that keyword as to delineate that this is an alias. So I say, here's my calculation, rental rate times rental duration as the rental cost. Okay? And so that's really helpful. That's really helpful to be able to alias your results. So not only can I have columns in here. I'm going to save this somewhere so I have it. So I can not only pull columns directly, but I can also add additional virtual columns. I can make them up. Okay. So that's part of the select. Another thing that's worth doing in there, let's try that one real quick. So select star. So I'm going to put another query in here. Select count star from film. I'm just going to highlight this one query and run that. Okay. So that count star tells me how many rows are in the result set. Whatever query I built up tells me how many rows am I getting back. Make sense? Pretty simple. Really helpful though. Really, really helpful to know how many rows you're getting back. ignore the star in there for a moment. That star in there is kind of to tell what column you're looking at, but generally speaking, it's going to be a star. It's usually not going to be anything else. Notice the name of the column, right, is count star, right? That's kind of a problem because, well, pull that into my code. That's not a valid JavaScript variable name. So I need to give that an alias, right? And so remember, we just looked at how to do aliases, right? So anytime you do count star, you should definitely alias that, just like we did with the other one. So I might say this is as count, give it that name, and go ahead and execute. And if I wanted to be more descriptive, I could say as the film count. Now there's some interesting things that happens with count, namely that you notice that I'm not returning any other columns. Do you see that? And notice that I went from how many records? I went from a result set that had 1,000 records, right? This right here had 1,000 records that came back, but count only came back as one record. Do you see that? So count kind of, what we would say, it groups the data together, collapses it into one record. Okay? It's a little bit more nuance to it, but that's basically how that works. So that means I can't then go do things like, hey, give me the count and the title. Doesn't really make a lot of sense. MySQL says it's okay with it. Other versions of SQL will just say, I can't do this at all, because what title do you want? It can give you any of the 1,000 titles, but it's only able to give you one row, so it has to pick one, right? So generally speaking, if you're using count, you may or may not be able to use any other columns. Does that make sense? So that's part of what happens there. And it looks like it gave me the first one, as it turns out, and I think that's because of how MySQL decided to implement. They just say, hey, rather than throw an error, we'll just give you the first record. But most databases at that point would say that's not a valid query. Okay. So that's kind of the quick intro to the select clause. Let's go on to the next clause. Okay, so the next clause is where we say, what table do you want to pull the data from? Okay, and I kind of already used that. I already said I'm going to pull it from the film table. So I can say it pulls from a single table, from the products table, or I could actually pull it from a few tables. I could pull it from products and customers. Okay? Now, when I pull it from products and customers, it's going to do something called a cross join. And what it does is basically it creates a very large result set that has every possible pair of product and customer. So if I've got 1,000 customers and 1,000 products, this right here will give me back 1,000,000 results. And I'm not kidding about it. This right there, you can start from 1,000 of one thing and 1,000 of another, and it will give you back 1,000,000 results. Have you heard about a denial of service attack? Yeah, I mean, in enough cross joins, you can make a denial of service attack because that takes so long. You can shut down your database because it's working on satisfying somebody's complicated query. Okay. So we can do that, but let's just see what happens when we do that. So let's see. I've got film and store. So maybe let's see what happens if I try to pull both the film and the store table. So select star from film, comma, store. We can see there's a lot of records. Okay. Now, I think I need to do these individually. select count star as store count from store, because this does not seem right. Okay, so if I run those two, there's 2 stores and 1,000 films. Okay, so I should see that here. So interesting things, right? Do you see how there's 2 Kiss Glories? There's 2 of every movie. See that? There's 2 copies of every given data, because I'm joining those 2 tables together. Remember, there's 2 stores. So for every film, it's going to add in 2. Okay. So if we look at the data here, you're going to see on the left, we're going to see most of this data is most of this data is going to be from the film table, until we eventually get over to the right, and these columns over here are from the store table. So you've got the store columns joined, put together with the film columns, right? So if I had 10 columns in one and 5 columns in the other, this has now got 15 columns. Make sense? So that's what you get from a cross join. Again, it's take every pair of every set of every record from here and every record from here and come up with every combination of those 2. Comes up with whatever records you have, it's M in this table, and in that one it's M times M. That's what you're going to get. You're going to get the multiplication of the 2 sides. Okay. So I can do that, but that's generally not terribly useful for me because, well, the rows here and the rows here don't really have anything to do with each other, right? There's no connection between the film and the store. If I was to look at relationships, there's no relationship, there's no foreign key between those 2 things. So while I can do that, it's not always all that helpful. Okay, but that's the kind of thing to remember there. The from clause can contain one table, it can contain multiple tables. Generally, it's going to contain one table, unless you do need a cross join of some sort. Let's talk about joins, okay? So if you're talking with a simple select is only pulling data from one table. Oftentimes, you're going to find that you need data from multiple tables, okay? Now, when you're putting that data together, that data is generally the way you do these joins is generally going to follow your relationships, right? So if we're looking at, let me pull up my diagram from the other day. Where did it go? If I, for some reason, needed information about assignments and teachers, right, there's no direct connection to them, right? So, like, if I want to pull the data together, I'm going to end up needing to pull teachers, courses, and assignments. Okay. So, a join, in particular, pulls together 2 tables that are generally related, okay? Generally speaking, the only time you're really going to join 2 tables if there's a relationship or a foreign key together, right? You can technically pick any 2 tables and join them together, but generally they follow your relationships. Okay? Generally speaking, they're going to follow your relationships and foreign keys. They have to, not necessarily, but they usually will. Okay? So let's say one of the common things that might occur is I might want to say, okay, give me all the assignments for a course, okay? But within there, I want to know some information about the course that they go with, right? if I look at the assignment table by itself, does it tell me the name of the course? Doesn't, right? Assignment table doesn't tell me the name of the course. So if I want the name of the course, I need data from the course table and data from there. So it's a join is a way to put data together from two different tables. Okay. So if we're looking at the one specifically on this slide, we're saying let's take orders, order product, and product. So I'm going to get some information about what's in the orders and some information about what's in the products. So I might start with my orders. I have some sort of, we kind of see there's a bridge table happening there. So that bridge table is kind of the bridge of like, well, what products did you order, right? And so we would say, okay, join order product. This OP here, this is an alias because these table names are long. So I'm using OP as a shorthand for the full name of the table. Here I'm doing orders O. Order O is an alias for the orders table. With me? Okay. Oftentimes these joins get complicated enough that we need a shorthand for the name of the table. So that's what we're doing. So orders is O, order products is OP, product is P. Okay. So when we join these two together, orders and order products, I'm going to say I need to join on a column that exists in either table. So here I'm saying let's join on order ID, join that to an order product order ID. So basically there's an order ID in both columns, which gives us a relationship. I'm going to say let's combine those together. So let's only get the records, only combinations, not all the combinations, just the combinations where those match up. Does that make sense? Only the combinations where the order ID is the same on both sides. And then I'm also going to bring in, the whole point of doing this is getting from the order to what products are in there. Well, I might want to know the name or the price of that product, so I jump down here. And so I say, let's also join in the products based on the product ID. So I've got OP, product ID, P ID, right? So that's the way that you kind of combine data from multiple tables. Sort of making sense? It's really weird. Joins take a little bit of time actually to get your head around. Okay, but that's kind of the syntax that you'll see. Okay. The thing to remember is you're going to follow those relationships. The part of what you have to figure out is for the query that you're trying to run, where is the data that you need, and then figure out how to join that table together and kind of massage it into what you need. Next thing, let's talk about conditions. Conditions, or the where clause. Okay, the where clause says, I only want to get some of the records. Okay, I want to filter down the result set. I want to say, I only want records that match these rules. Okay, so for instance, here we're saying, I only want products that are in the category of hats and have a price that's greater than or equal to $10. Okay. So filter out anything else that doesn't match those rows. So that means I'm going to have fewer rows in the result set. Remember, the select clause was to change the number of columns. Where is to change the number of rows. Okay. You'll notice here I could do this something really simple. I could just say where category is hats, or I could just have this expression. But I can combine multiple expressions together using the actual word and. You can also combine them, by the way, using or. So I could say or category hats or price is greater than 10, or I could do and. Those operators both work there. The operators are honestly very similar to what you've seen in most programming languages, where there's greater than, less than, greater than or equal to, equals, etc. Okay, so those are pretty simple. There are some additional operators that you can use in the where clause. Which I don't know if I have on these slides, but there's some other ones that are worth knowing about, such as there's a between operator. And between gives you a range, an inclusive range between two things, which is really helpful when you're working with dates. So I can say the start date is between A and B. So that can be helpful there as well. There's also a like operator. I don't know if that is on these slides. Group by. Let's talk about the group by clause. So the point of the group by clause is to group rows together into groups, right? Hey, I've got all of these rows. I'm going to group them down based on some conditions. So for here, I'm grouping products by category. So then if I have 5 categories, then I'll end up with 5 rows. Does that make sense? So I'll end up with a row for every category instead of a row for every product. Cool. Then I say, okay, select runs. And we say, okay, well, what columns do you want from this result set? Well, we want the category. I want to know what category each of these rows represents. And then I can do a count star. Count star will tell me, well, how many rows are in each of those groups. So if I run this query, I'll see, okay, I know now that each of these categories have so many records in it. Makes sense? So how many products are in each category. That's how we do that. It's worth noting, if I run this, and maybe I can do an example with this on here. Is there anything I can group by? See, looking at films. Films have a rating, so I could group by rating. So let's say we try this here. So select star from film. I'm going to start there. I'm going to select all the films. Bring that down a little bit. And let's say I want to group it by the rating. So group by rating. And then I want to return the rating and the count star here. So if I run that, there we go. So I can see, hey, PG's got 194 movies, G's got 178 movies, etc., etc., etc. That's really helpful, right? There's a lot of cases where you can use that to say, okay, I want to know based on this and this and this, how many things are there. Cool. So I can tell how many of there are. Or if I want to say, maybe I want to say what is the most longest viewed one. I might say, give me the max rental duration. And we're going to say this as max rental duration. And I can see, oh, well, that's not interesting. But apparently all of the movies have been watched for a maximum of, I guess, 7 days. Clearly there's a store policy at place that doesn't allow them to check them out longer than 7 days. What about the min? Can I ask for the min? Is the min going to be any more interesting? No, only if I run just that query. Oh, so apparently you have to. Apparently at this store in particular, you have to rent them out for at least 3 days, and you can rent them out at most 7 days. But you can kind of see I can put some things in here. So minimum is the minimum number, the lowest number, max is the highest number within that group, and I can say give me the number of records, right? So I can use these to kind of aggregate or group the data. Okay, grouping is really, really useful. Okay, in fact, grouping is kind of one of those non-obvious things where it gets used literally all the time to do all sorts of things that you wouldn't expect that you can do with grouping. A lot of problems that don't look like you need to group, you do need to group. In fact, one of those things I said, hey, distinct, right? You usually want to avoid distinct, right? In fact, oftentimes it turns out group is usually a better choice than distinct, which is kind of weird to think about. But oftentimes, actually, it works out that way. Oftentimes, it works out that the thing you actually want to do is group the data by something rather than making it distinct. Does that make sense? Distinct is just like throwing out random records. Like, well, I got something not working. I'm just going to put a Band-Aid on it. Is usually what distinct is. Distinct is usually just a Band-Aid. Having. Okay. Having's weird. Having's weird. Having in a lot of ways is like a where. Where and having have something very much in common. Okay, so namely, having and where can always contain what we call a predicate or conditions. Okay, can always have something produces true or false. Okay, so where says, do I want to keep this record? Don't want to keep this record? Where it comes out true, you keep the record. If it comes out false, you throw the record away. Same thing happens with having. Having comes out true, you keep the record. If it comes out false, you throw the record away. Okay? Are you tracking with me? So having and where are almost identical with one minor caveat. Okay? Where always happens before a group, having always happens after a group. Where always happens before the grouping, having always happens after the grouping. So for instance, if I want to say, let's group it by category, in this specific cases, I'm saying group it by that, and then only keep groups, only keep categories that have more than one record. Does that make sense? So I group it, and then I can check the count. Oftentimes, you do actually use these together. So I might say, okay, for instance, maybe I say I only want products that are $10 or more. That would be my where. I group it down, and then I see, how many things are in each category, and maybe I throw away categories that only have 5 things in them or something like that. Okay. Usually, you're throwing away. This is pretty common to throw away all the groups that have one thing in them. That's really what this does. Say, oh, I don't care about all those things because I can find duplicates. Because duplicates have 2 things or more in the group. Does that make sense? So having is actually really useful. It's one of the lesser known clauses in SQL because it doesn't get as much use as the where clause, but having is actually really, really helpful. And then coming down towards the end, we've got the order by. Order by says what is the order that you want the results to come back in. And so for instance here I could say let's order it by the name of the product. I can either do it in ascending order or descending order. So from the lowest to the highest or the highest orders. It'll work whether that's a string, it'll work whether that's a date or a number. It works for all of those different data types. You don't have to do anything magical for that. The only thing that ascending and descending doesn't work with is text columns and blob columns and binary as well. So I can't order by text, binary, or blob. I can order by anything else. Cool? That's really helpful. As I mentioned in the preface to this, we really want to make sure that all of our select queries have an order by clause so that we know what the order is going to be after we run the query. And I think my text here is incorrect. Because that's referring to the order by clause, or the group by clause. So something happened there. Last up is the limit clause. The limit says, I'm going to put a limit on how many results I get in the result set. It's a hard limit. Can't be above this. And there's a few versions of the limit. There's 2 versions of the limit. I can either say like this, I'm saying, hey, select from the products, order it by name, limit 10. So this is just going to give me the first 10 results. Does that make sense? You can also put in there an optional offset. If you don't put an offset, it assumes the offset is 0. But the offset says, I want to go further to maybe another page. So, or skip some records. So this says, let's skip the first 20 records and then give me 10. So if you're trying to put these into pages, you see pages all the time on websites. You want to say, hey, I'm going to give you 10 items per page. The first one would be 0, 10. The next page is going to be 10, 10, 20, 10, 30, 10, 40, 10. So this is actually how we implemented paging, is between this offset and the count, the limit. Cool. So that's really helpful. It's worth noting, never use limit without an order by clause.
You're talking about Asian? What about offset and fetch?
What do you mean offset and fetch?
Isn't there a fetch? Yeah.
Are you thinking of a different version of SQL?
Possibly.
Possibly. It's worth noting that offset and limit doesn't work the same in every version of SQL. Everybody's decided to do this differently. So I think most versions of SQL have a limit clause, but nobody agreed on how to do the offset. So this is the way MySQL does offset and limit. But if you're working, say, in Postgres or SQLite or Microsoft SQL or Oracle, you're going to have this syntax is will probably not work. It'll work a little bit different because there isn't really a standard for how to define the offset. That really depends on the database you're working with. So you might be thinking Microsoft SQL. I don't remember what Microsoft SQL's version of that is, but I do remember it's more of a pain. That's what I do. So that's what we do. That's how we're going to do this. It's really important that you have an order by clause anytime you do a limit. Because remember, you don't know what order your results are going to come back in. And so if you don't order them and you ask for a limit, well, it's taking limit 10, says take the first 10 results. If you're not ordering it, you don't know what 10 results that's going to be. Again, for all intents and purposes, it's random. In fact, it may be that the user refreshes the page and it's another 10 results. Refreshes the page and it's another 10 results. And you don't want that to happen. That's like worst case scenario. There's a lot of things that can make that happen, but that's things to be wary of. So with limit, you always need to use an order by. Okay, so we looked a little bit about what some of these clauses are. One of the things that's really confusing about SQL is because when you're writing SQL, you're not actually telling the database what to do. You're kind of giving it some loosey-goosey instructions. We call it declarative programming because you're kind of declaring what you're wanting. But unlike in like C# or JavaScript, you're not telling it how to do it. You're not telling it how to get the data. You're just telling it, here's the data I want. You figure out the best way to do it. Now, because of that, the order that you write the queries doesn't correlate with the order that it's running. Okay, and you might ask, well, why do I care about the order that's running? It turns out you do, because it will change what's valid SQL and what's not valid SQL. Okay? So there is an order that these clauses are executed in, and you do want to make a note of this. You do want to actually ingrain this in your memory and remember it, okay, about what this order is. Okay. So the first thing that happens is the from clause. From is the first thing that happens. And where does that exist in the SQL query? It's not the first thing in the SQL query. It's the second thing, right? Select star from products, or select title, name, and description from products, right? It's the second thing, but it's actually the first thing that happens. One of the things I actually tend to do, I write my queries generally in the order that they execute. because it's just helpful to test them and debug them that way. So from gets executed first. That says which table are you going to start with, or tables. So I might start with the product table. Next thing that happens is we do the joins. Okay. So we say which table is it going to come from. Let's do the joins to combine data together. Thirdly, you can think of it as doing the where. Okay. So it's going to say what data do I actually want to keep. In reality, it's kind of weird because oftentimes join and where get intertwined when the database actually runs those. But you can think of it conceptually as if where happens after the join. Does that make sense? Sometimes they happen at the same time. But you can think of it that way. So join the data and then decide what data to keep. Okay, so if it matches the where clause, you're going to keep that data. Next up is grouping. So you group the data there. You do the having. You'll notice that the having, as I said, is run after the group by. Having is run after the group by, where is run before the group by. Right around it. Okay. Then, at least in the way MySQL runs it, we do a select. That's when we actually go back to the first line of the code, line of your query, and say which columns you want to keep. It runs any of those expressions. So say you want to have a count. Let's say you want to multiply the rental duration and the rental rate. You want to multiply those things together, create some columns. That happens here. Okay. Which then means you can actually order by some of those virtual columns that you created. Does that make sense? So if I create a count column, I can then order by the count because it's available at this point. Does that make sense? So in your order by, you can actually refer to columns that you created in the select because they're run in that order. It's weird. That part is very weird. This select should not have been in the place where it is if SQL was to make a lot of sense. The query, the select really should have moved down here, in my opinion. But it isn't. So we do the order by, and then the last we do limit. Limit being last kind of makes sense. Cool? So take note of that. I would really recommend you kind of write the order, write them in there. That means oftentimes I will keep my select, the select star, until I get all the way down here. And then I'll figure out which columns I actually need to keep. So that's actually not the first decision I make. Usually what columns I select is the last decision I make. Just saying. Cool?
I've kind of gone through that too.
Yeah.
I was writing it out, but the formality sake of just three selects on there until I figured out what it was.
Yeah.
I was actually editing lines below it. From and joining the ring.
Yeah.
Before I realized what it is I want.
Exactly. You usually don't know until you get all the way to the end there and like, okay, now I know what columns I want. Now that I've done all the other things. So that's one thing that gets confusing, but it's kind of how you do it. Okay, so let's talk about aggregate functions. We talked a little bit about some of these already, but I want to talk about the ones that are available. So there's the count. That's pretty simple. Count star just says how many results are in your result set or how many rows are in your group. Okay. You can do count column. So if I say count name, that will tell me how many rows contain a name that's not null. Does that make sense? If you specify a column, then it's how many things are not null. So count star is generally going to give you a larger number than count with a column in there. Okay. This is very rare that you want to do this. This is really, really rare that you want to count the number that they're not null. That's extremely unusual. The next thing you've got is a sum. So a sum is going to take that column, add it up. So let's say I want to take the price. You select sum price from products. This would be the total price of all the products, right? I can also put an expression in there, sum A and B. This would go for each row, take A plus B and add up every row. So you can put multiple columns in there. Or I could say, like, take A times B and then add those together. You might think of this, the common place where this comes up, if you're thinking about orders, you might say, well, what are the things in my order? Each of those have a price and each of those has a quantity. So I might say sum of price times quantity. Does that make sense? Sum of price times quantity would be your whole order total. That's how we would do that. You can also take an average. So I can say, what's the average of a column? I can do that with an expression as well if I need to, but usually we're doing that with a column in particular. I can also say min or max. So give me what's the minimum value in the table, what's the maximum value in the table. Any of those where I've said column, you can do an expression as well. Okay, so it can be a single column or it can be an expression. So those aggregate functions are really helpful. Okay. So let's talk a bit about joining. Okay, I kind of skimmed over that in a bit because I remember that we had earlier here because I remember we had some slides about it. So joining tables in SQL. Joining tables is kind of interesting. So joining, remember, is a way that we combine data from multiple tables. But it's worth noting when we get that result set, it's still going to be a flat result set. Okay. When we get that result set, it's not going to contain any sort of hierarchy. Like this will, like the student belongs to the course, or the teacher is connected to this course, and vice versa. You know, the connection between products and orders and order lines and all those kind of things are not preserved because we still have to have a table at the end, right? At the end, the result has to still be a table, has to still be flat, okay? That's important, regardless of what join we do. So a lot of times that means taking your smaller rows and putting them together next to each other, as we kind of saw. Take a row from here and a row from here, join them together, and you get a longer row. Okay? With data from both tables. Okay, so talking about a cross join, we saw a little bit about that. Here's a kind of a smaller example so we can see how that works. Here I've got products. I've got 4 products. I've got 4 customers over there, right? How many rows am I going to have if I do a cross join? How many rows in the result set will I have? Remember, it's rows in here times rows over there. So the result set here, if I do a cross join, is going to be 16 rows. Okay? Remember, I could have written this as from products, comma, customers. It's the other way to write a cross join, or I can actually write out the word cross join like this. I can actually write that out. That's another valid way. Okay, so we see ball, hat, glove, bat, John Doe, Mickey Mouse, Minnie Mouse, and Donald Duck. So when I go to do a cross join, here's the 16 records I get. Okay. The first 4 you see are for the ball. The next 4 for the hat, the glove, and the bat. Right? I have a lot of duplicate data. Okay? Because I've got 4 for every one. Similarly, if I look at each of these, if I look at the ball, there's 1 of each customer. Hat, 1 of each customer. Glove, each of the customers. Bat, each customer. So I got 1 for each combination. So that's what a cross join gets you. Okay. So the other joins are going to give us less data than this. Like this gives us all of the rows, all of the possible combinations. The whole point of the other joins is to get fewer results than this. Make sense? Okay. Because this is usually not what we want. There are some cases where that's what you want, but that is pretty rare. So let's talk about an inner join. So an inner join here, I might say, let's take the order items and the products. Okay. So here's the order items. And see, hey, they've got an order ID, product ID, quantity, and a price. Okay, so that's the columns over there. When we look over the products table, it's got an ID, a name, and a price. Okay, so if I join these, I'm going to say, let's do an inner join. And I only want to keep those rows where the product ID on here matches up with the ID over there, right? Rather than that full cross join, I just want the ones that match up. Cool. And so then the ones that match up are just these, just 4 records. So I don't have a bunch of duplicate data. Turns out, each of these rows refers back to one product. What's the relationship, by the way, between order items and products? What's the relationship there? What kind of relationship do we have? So here's the end. There's a product ID over here, right? So that kind of looks like a foreign key. Foreign key is on the which side of a relationship? It's the many side. So this is a many to one or one to many, right? So for every product, there may be many order items for it, right? Many people can order that product. But every order item traces back to, is only connected to one row. So I know if I take these and join these, I should have just as many records actually over here as in the results. But things to pay attention to, okay? So we combine these things together. So I've got all of the rows here, order items dot order ID, order items dot product ID, order items dot quantity, order items dot price, and then I've also got products dot ID, products dot name, and products dot price. Make sense? Okay. Now you will notice I've got some duplicates here because I've got a product ID here, and I've also got a product ID. So I've got 2 columns that have that in here. I also might notice what? I also might notice that in here, notice my product IDs, 1, 2, 1, and 3. One of my product IDs is missing. Do you see that? There's no bat. There's no bat over here. There's no product ID 4. Why? Well, because nobody ordered that. Nobody ordered a bat, so it's not in these result sets. So if I'm trying to do sales figures and see what items sell the best or what items sold the worst, well, bat doesn't even show up on that report. It's just like, okay, nobody ordered it, it doesn't exist. So it's worth noting there in an inner join, you often run into this case where things in one table just kind of disappear. Does that make sense? Because there's nothing, there's not something on the other side for it to be connected to. Let's talk a little bit about set theory. Remember that we as I mentioned actually in the prelude to this, I said, we can treat our tables as sets. In fact, you can treat your results, the result of your SQL query, as, well, it's a table, so it's also a set. Okay. So you might have seen these Venn diagrams. Anybody remember seeing these in math class? Okay, Venn diagram, you've got these kind of intersections. So you got table A here, which is this set. Table B is the other set. You've got this area in the middle, is referred to as the intersection, the place where they overlap. So you can use that to kind of think about this. So there's the intersection, is the area in between. The whole area is referred to as the union, okay? So you got the intersection, which is the area in between. The union is the whole thing. We also talk about the subtraction, okay? Subtraction, here we say A minus B leaves this, right? This is all the area that's not in B. Or I could do the reverse. Okay, so that's kind of some terminology that you learned about in math class. And so if I draw a little bit of an analog to joins, joins are kind of similar. So a lot of times a lot of us think about that inner join as being that intersection. It's the place where they overlap. Does that make sense? It's going to give you the fewest number of records. You only give those records where there's an overlap in your join conditions. If I, on the other hand, do a left join, okay, because that's one thing I can do, I just put the word in left instead of inner. If I say a left join, that gives me this. Instead of just the intersection, it gives me this. So left join is going to give you more records back. Okay. So specifically, a left join gives you records that don't match up to a table on the right. Does that make sense? So if the row exists in the first table, but there's no matching record in the right table, you'll still get the result. Vice versa, if you do a right join, if there's any data in table B that doesn't match up to table A, you'll still get that data. Okay? So right join's giving you more records from table B, a left join's giving you more records from table A. Okay. Sometimes you'll also see a full outer join, which is that whole set. Okay. It's worth noting that cross joins really can't be represented as a Venn diagram. Basically, the right way to represent a Venn diagram is as a grid or a cube, is one way you can think about it as cross join. It's like a cube, but it doesn't really work as a Venn diagram. There's also in SQL, there is actually a union statement. A union statement takes these records and just kind of adds them to the end of each other. You can kind of think it like concatenating two lists. So I can concatenate this list with this list, and that will give me the union. With the addition that union also actually typically removes duplicates automatically. Unless you tell it to not remove duplicates, it generally removes duplicates. But it's worth knowing, union is not actually a join. Okay, union doesn't function as a join, but it's worth to know about. So if we're talking about joins in SQL, we looked at some of those. So this would be an inner join. So I'd say inner join order items with products. Look like that. I could also say let's left join. The only thing you'll notice that changes is I put the word left there. So inner left or right. You can put that in that spot. If you just say join, it presumes that you mean inner join. Okay? If you just say join, it's going to presume that you want it to be inner join. Okay. I actually found out in practice, more often than not, I use left joins. I've actually found left joins to be more helpful than inner joins in a lot of cases. So that's actually what I use most of the time. Vice versa, I found that right joins are the ones I avoid. But it's worth noting that all three of those exist. If you do need to write a union, it's going to look like this. Select star from boots, union select star from hats. So it's going to take all of the records from boots and all the records from hats and put them together in one result set. It's worth noting for a union, both of these two tables have to have the exact same columns. Same names and same data types. Otherwise, you just get an error and it says, I can't do this if they don't match up exactly. But you can match up two queries that way to put them under one. So that's kind of the quick and dirty introduction to select queries. There's a lot more examples if you watch through the homework videos, the playlist. You'll find a lot more in there. But that's kind of the quick introduction to running select queries. Okay? How's everybody kind of feeling about that?
A lot to take in.
There's a lot to select. I mean, you can spend years learning more and more about select queries. That's no joke. I mean, my experience in the industry is I was constantly learning new things that I could do with a select query that I didn't know was possible. Or learning that certain things were slow that I thought were slow that I didn't think that were slow, or things that are fast that I didn't think were fast, and you constantly learning things about optimizing it too. So it's a pretty big set of clauses and things that you can learn. Okay. But it's really a case of you want to get familiar with all of them. There's a reason that they exist, and in fact, it's pretty common to use all of them. All of them actually come up pretty often. Any questions? Yes.
Can you explain the on a little bit better? Like, so products and on?
Yeah. So on, you can kind of think of it like a where, right? You can say this has to be true. If it's not true, then we don't keep that record. We only keep the record, the pair of record A and record B, row A and row B, if that is true. Does that make sense? You only keep it if that's true. If it's false, you don't keep that record, right? So you think about the cross join. Cross joins that whole huge set. Basically, the slow way of thinking of it is you get all those results, and then you just decide which ones to keep. The database is actually usually a little bit faster than that, than doing the actual cross join, but that's one way you can think of it.